eyes and brains create perception of different colors. We sense a range of colors, a spectrum, with one merging gradually with another. Towards the middle of the spectrum is the color yellow. Most of us will agree that this is yellow. Somebody told us, probably a long time ago, that it was yellow, and everybody else seems to go along with that. It's a social agreement. Yellowness of color exists in public space. It takes on meanings that we all share. What goes on in your head has a lot to do with past experience in the public world. But your head is not public space. Nobody can know exactly what goes on in your brain, in the darkness inside your skull. Is what you feel the same as what everybody else feels when we all look at the same yellow light or object? Things quickly get more complicated. Yellow is not a single, very definite color. It's a range of colors. So how about this? Or this? Does what we experience depend on language? Some languages, such as English, have separate single words for red and light red, pink. Other languages do the same for blue. Other languages again have just one word for both blue and green. Wherever the light comes from, things happen inside our eyes. The retinas of our eyes have walls of nerve cells of different kinds. Some are the cone cells, 3 kinds, each kind seemingly responding to a different range of incoming light, different wavelength ranges, different colors. In some of those cells, green and near-green light trigger nerve impulses that pass along nerve fibers to the brain. The green cones respond to a range of color. In fact, they respond to quite a wide range. Other kinds of cell, the red cone cells and the blue cone cells, produce nerve impulses when red and near red light or blue and near blue hits them. There is a problem with cone cells. They don't work in low light. Fortunately, you have backup, another kind of cell, rod cells, shown white in these images, that keep on creating nerve impulses when the light gets a bit dull. But rod cells don't respond to different colors, so you can't see colors when it gets too dark. If we only have 3 kinds of cone and rods are totally colorblind, how can we see so many colors? Yellow light, for example, can trigger some green cone cells and some red cone cells. A color TV really does have only 3 colors, red, green, and blue. We see the in-between colors thanks to different combined brightnesses of the little red, green, and blue lights. Some bright blue with some green light from the screen gives the color cyan. Red and green work together too. Your eyes are still using only 3 kinds of cone cell, but the right mixes of impulses result in perception of yellow in your brain. Blue and red lights combine to give magenta. And all 3, red, green and blue, give white. The complexity increases some more when the nerve impulses arrive in our brains. For example, it's not only a matter of red, green and blue combinations, but what we believe we see depends a lot on background color. Those small stripes in between the magenta and the yellow are in fact the same color, but when we first look at the star, they don't look the same at all. What we think we see still depends on what's out there in the world, but the complications produce some surprises. So which is best, an analytical approach to color, or a more immediate, more emotional response? Or there is very thoughtful experimentation with the impact of color, as in this painting of London Bridge by Claude Monet. There are different ways at looking at the world, and they are all better than living with closed eyes.